Alright, the computer shut down, so this is where we left off. And let's check for the negative zeros. This would be a negative x times negative 3. That's a positive 3. Positive times negative, negative, and we have positive to negative to positive. So we have 2 or 0 negative zeros. And then we'll take a guess. And let's guess 4. So that tells us that 4 is a 0. And we also see that 4 is not an upper bound. So let's try 6. 336. So we know that 6 is not a 0. Let's try 3. I used the original polynomial here. Why don't we use this polynomial? So 3 is a 0. We want to use 4 and 3. And so when you're trying problems, you just have to keep guessing zeros, and you try them until you get down to 3 coefficients, and then that'll be a quadratic. So now we have g of x is x minus 4, x minus 3, and then we'll have x squared plus 4x plus 4. And this factors like that. So now we know that the zeros are, if we set this equal to 0, each of these equals 0, and that means we get x equals 4, 3, negative 2, and these are the zeros of the polynomial. We also, if it has the, if the degree is 4, then it's going to have 4 zeros. This one does have 4 zeros, it's just that the negative 2 is repeated. So we have q equals 1. Pause and you try this one on your own. Go for the possible rational zeros, Descartes' rule of signs, and then test the possible zeros using synthetic division. And we have a lot of possible rational zeros. We're going to have all of these divided by this, and so we'll just have the same as that. And Descartes' rule of signs, we're going to look at how many sign changes it has. Positive, positive, negative, negative to positive, positive to negative. So we have 3, 4, 1, positive, 0. Let's check the negative. And we'll go, that'll be a positive, negative, positive times a negative. And we have positive to negative, negative to negative, negative to negative to negative. So we only get 1, negative, 0. And now we try synthetic division. And let's try negative 6. All right. Now we have one negative 0. Here's the negative 0. So we make sure we don't check any more negatives. And we could keep trying synthetic division, but if you notice this pattern 1, 5, 4, 20, this is factorable. So if you ever see something that's factorable, then just factor it instead of guessing. And if you have, that's not a 4, that's a 3 and a 2. Okay, let's factor that. Here's a way to factor it. We factor out a negative 5. Factor out a 4 and an x squared and an x. So make sure that all works out, and we'll have x minus 5, x squared plus 4. We also have x plus 6 from here, and those are the factors. If we set it equal to 0, we're going to get x equals negative 6, x equals 5, and x squared plus 4 equals 0. This is going to give us imaginary zeros, and we're going to get x equals positive or negative 2i, because we're going to go square root of both sides, and we get an I from the negative, and square root of 4 is 2. So we have the zeros are negative 6, 5, 2i, and negative 2i. And also see that is a 4th degree fourth degree, and we have 4 zeros. All right, that's it.